Good morning, class. Today we're going to be doing the serum protein electrophoresis procedure. The principle behind it is proteins are large molecules composed of covalently linked amino acids, depending on electron distributions resulting from covalent or ionic bonding of structural subgroups. Proteins have different electrical charges at a given pH. In the Helena serum protein procedure, the proteins are separated according to their respective electrical charges at pH 8.8 on a cellulose acetate plate, using both the electrophoretic and electroendosmotic forces present in the system. After the proteins are separated, the plate is placed in a solution of sulfosalicylic acid and Ponzu S to stain the protein bands. The staining intensity is related to protein concentrations. After dehydration in methanol, the plate background is then rendered transparent by treatment with a clearing solution. So class, we're going to be doing the step-by-step method. And the first thing we have to do is the Titan 3 platelet preparation. So the things that we would need to do this part of it is the cellulose acetate plate. We need the electro HR buffer. This is how the actual plate looks like. One side is hazy or dull, and the other side has a gloss. The side that is dull is the actual cellulose acetate plate. The instrument that we have to use is called a bufferizer. The emphasis on this particular instrument is there is an opening which allows the HR buffer to run down the sides of the receiving part of this instrumental container, which what we want to get at the end is no bubble formation. So I'm going to fill the container now with the HR buffer, and you will see that the buffer runs down the side of the container. So class, once you have placed the amount of HR buffer that is required for the bufferizer, we then place the cellulose acetate plate slowly, and this now soaks for 20 minutes. The next method that we're going to do is the electrophoresis chamber preparation. So this is the chamber, and there's a particular way to open it, class. So I want to emphasize on that. So this particular piece here, and this is the cover. So you place your thumb, that's how you open the chamber. The HR buffer is placed on the two outer regions, and 100 milliliters of the HR buffer, which is measured here, will be placed on either sides. The next thing is we are going to put the wicks. The very first thing we have to do is place it in the solution and we are going to create a bridge. So the bottom piece of that same said wick must be in solution. Then we're going to fold it over. And the same has to be done to the other side. The next thing is the sample application. So in the sample application, we need to have where we're going to be actually placing our samples. It accommodates 8. The very first one, we will put a control. In this case, it's a normal control. What comes with it is the applicator, which also has 8. So I can align the two. You then see that 1 to 8 lines up with the 1 to 8. That's where you're going to place the sample. A technique in the actual application is how we hold the actual pipette. Now, perhaps a normal person who does not do anything to do with MLT may just hold it. They may hold it like this, but in our profession, we need to have it this way. So if we hold it this way, what you notice is you actually have the pipette at a 90-degree straight in order to add your samples. I'm going to be placing the serum sample into we place 3 microliters of sample into each of the wells. After that, we have to prime the applicator. So this is the applicator here, and so we're going to depressing the tips into the sample wells 3 to 4 times. So as I said earlier, it lines up. So this is where you're going to be pressing 3 to 4 times. One, 2, 3, 4. After that, we blot. And then we prime. Priming the applicator makes the second loading much more uniform. Do not load applicator again at this point, but proceed quickly to the next step. So the next step includes removal of the actual cellulose plate that we were soaking for 20 minutes. So once that is removed, We are now going to put it in our aligning base. This is the aligning base, and for this particular application we're using the center application. But with that, we need to have it being readily available, easy for us to slide it out after we've applied the serum sample. So class, we have to ensure that it's the dull side that is facing upwards when we do the actual application. So as I said, it's the center application, so we're going to line the bottom piece to that line. We're bringing across. Now that we're ready, we have to, for the application, we have to take it over So we remove the Titan plate from the buffer. Before placing the plate and aligning place a drop of water, which we did. This prevents the plate from shifting. We're using the center application. We did the 3 to 4 times. And now we're going to hold for 5 seconds. Class, in order to do this procedure, it requires us to have a power supply. The power supply needs a voltage of 180, and the chamber, electrophoretic chamber, has to be attached with the leads. So there's positive and there's negative. We have positive and negative, and positive and negative. So you need to do it either on the left output or the right output. In this instance, we'll use the left, which is closer. You need to press on the clips in order to pressing the clip. Remember earlier we placed 1 drop, so we are now going to to take it out by sliding, lift, and always place your cellulose acetate side down. Place the cover, and the procedure can now start. So this is the entire setup class. So you're going to run it for 15 minutes at 180. So this you turn at 15 and you start. So class, in order for us to know that the actual procedure is working, we'll actually be seeing a misting in the area, as you can see. Alright, so 15 minutes. Class, so after the electrophoresis takes place, we now take out, we'll be taking the plate through the staining in order for us to visualize the bands. So the stain, it's called Ponceau stain, and then the Ponceau stain, it's going to remain there for 6 minutes. So the very first one is 6 minutes. After the time is up, we then have 3 successive 2-minute washes of 5% acetic acid. So 2 minutes, 2 minutes, and 2 minutes. Then after that, we go through dehydration. Dehydration with methanol. And in that one, we have 2 minutes again and 2 minutes again. After that is placed in clear aid for 5 to 10 minutes. After you've taken it out of the clear aid 5 to 10 minutes, you have to ensure that the side that is dull is facing upwards, and we're going to put it in the incubator to dry. So it remains in the drying oven, which was set at 50 to 60 degrees Celsius for 15 minutes. So after that, we will now be able to see, as you see class, earlier it had a white background, and now what we're seeing is a clear background. So that's what the clear aid does, and this is the end product now, wherein it shows that the position 1, as mentioned early in the procedure, you place control 1 and then you have the other patients.